Alright guys, so chapter 10 is kind of broken into two different parts. The beginning of it is exponential functions, and the second half of it is logarithmic functions. Okay, so start with the exponentials. It's a little bit easier, right, because we are a little bit familiar with these. What we're going to do is we know how to work with exponents when they are positive or negative integers, okay? But what we're going to do is, the goal here is to extend that meaning, or extend our ability to work with exponents to include all rational numbers. Now remember, rational numbers are numbers that can be written as a fraction. Okay, so it doesn't necessarily have to be an integer now. Now it could be like to the 1/2 power, to the 5/3 power, whatever. Okay, so a rational exponent, it looks like this. Okay, so b to the p over q power, right? B to the p over q power, right? P over q would be my rational number, because it's a fraction. Can be written as the qth root, all right, the q root of b to the p power. So the numerator goes as an exponent to your base, and the denominator is the power of your root. Okay, so all kinds of things that we're able to do with this. We're able to use positive fractions. Okay, so for example, let's just make something up. 2 to the 4/3 power is going to be 2, well, the third root, cubic root of 2 to the 4th. Okay, and we can obviously work that out a little bit more. You can also do negative fractions. So if you have, let's say 3 to the negative 1/3. Okay, 3 to the negative 1/3. Remember, you just treat that as a regular negative. All right, the negatives just mean reciprocal, so 1 over 3 to the 1/3, and 3 to the 1/3 we can change to the cube root of 3 to the 1st, or just 3. Okay, so those would be the same. And with a decimal, you just convert back to a fraction. So if you had, let's say 5 to the 0.8 power, right, well, convert that to 5 to the 4/5 power, which we can make the 5th root of 5 to the 4th. Okay, so those are just some real basic things of what we could do with these. All right, this one term that you're going to see written a lot in this and in your book is exponential form. Okay, so that means you have a product of powers only. So if I ask for something in exponential form, I want all powers, all exponents, no roots. Right, so I want you to convert from the roots back to the powers. Okay, so basically the opposite of what I just did. Now, we're going to simplify some exponential expressions, do some of that. All right, it's just very similar to what I just did, but we're actually going to simplify now. So we can convert this to the square root of 81 cubed. Okay, right? The 2, you don't need to write the 2, but it would go there. We just know square roots look like that. Now, you could do this a couple different ways. Let me show you. One way you could do this is obviously type in your calculator. 81 to the 3 over 2 power. Make sure you are aware of the 3 divided by 2 all ending up in your power as an exponent. Right, so based on your calculator, might need to use some parentheses there. Yeah, so that'll be helpful. You should get 729. Now, there's a couple other ways to do this. You could also do 81 cubed, and then take the square root of that number, so the square root of that 531,000 number, and you're going to get 729 again. Right? That works obviously the same way. The easiest way is, if you can, you could do this almost in your head, not quite in your head, but you could at least simplify it some. You could do the square root first. Do your root first if you know the root, because that's going to give you a smaller number to just work with this kind of in your head. So do the square root of 81 first, which is 9, and we know it's just 9 cubed. 9 cubed, you probably need to plug in your calculator, unless you have that memorized. It's 729. Okay, so those are all different ways to accomplish what we're trying to do. Okay, so for number 2, same concept, but since we have a negative exponent, it's going to be 1 over 8 to the 5/3. Okay, that should be an exponent. I can draw my 8 bigger. There we go. Okay, so this is 1 over cube root of 8 to the 5th. Okay, once again, you could do this all in your calculator, but I'm going to show you a non-calculator way to do it. You could literally do this problem in your head. Right, it's just going to be helpful when we get to later things if you challenge yourself rather than just rely on your calculator, because you're going to need to do stuff like this later. Okay, so we can take the cube root of 8 first. Cube root of 8 is 2, and 2 to the 5th 2 times 2 times 2 times 2 times 2, yeah, is 32. So 1 over 32. Right, if you plug it in your calculator, hit math fraction, enter, you would still be able to get 1 over 32. Okay, so that's at least a good way to check your answers. Now you can simplify radical expressions as well. This one, we've got all kinds of messed up stuff going on. Okay, I don't want to do that negative 3/4 power right now. Okay, what I'm going to do is I'm going to rewrite this in exponential form, and that'll make it much easier for me. So I can rewrite that as 81 to the negative 1/3 power to the negative 3/4 power. Okay, so 81 to the negative 1/3 power. Right, 10 to the negative 3/4 power. Now remember, power to a power means you just multiply the exponents. So we multiply those exponents together, and we've got 81 to the positive 3/12 power. Okay? Now you might be wondering, with this fraction, can we reduce it? Right, this fractionary exponent? Yeah, you actually can. Okay? So you can reduce that fraction to 81 to the 1/4 power, and 81 to the 1/4 is just the 4th root of 81, which we know is 3. 3 times 3 times 3 times 3 is 81. Okay? If you type that all in your calculator, once again, you should get the same exact answer as long as you're doing your calculator correctly. Right? And number 4. Right? This is when you need to be able to start manipulating these equations. Right? So you can't multiply these two together unless they have the same base. So let's rewrite them both in exponential form. Right? Square root of 1/3 is the same as square root of 1 over square root of 3, which is just 1/3, right? 1 over root 3. Okay, and we want the same base. So we can't reduce this 3 to be of any power at all, but the 9 we can. Okay, we have the cube root of 3 squared, right? That way they have the exact same base. So the base 3, right? Now that they're similar, we can actually multiply those together. So let's write them both in exponential form. So we have 3 to the negative 1/2 power times 3 to the 2/3 power, the positive 2/3 power. Okay, so this one became that, and this one became that. Okay, and now to multiply those together, you keep the base, add the exponents. Okay, so we'll have 4/6 minus 3/6 is 1/6 power. Okay, and with that, you can't really do anything much more with that, but you can turn it at least back into a radical. It's the 6th root of 3. Okay, let's go to some more examples. Okay, so we're going to simplify, or get the simplest radical form, okay, for each of these, and we'll also write it in exponential form just like we did in the last problem. Okay, so for the radicals, right, we need the same base. We can't do anything without the same base, so we need to write this as 3 squared again, cube root of 3 squared times square root of 3. Okay, with that, let's write it in exponential form so we can actually work with it. So 3 to the 2/3 power times 3 to the 1/2 power. Right? Remember, you've got like an invisible 1 and invisible 2 there. That's why it's 1/2 power. Right? So you just add the exponents, keep the base. Oops, should be 7/6. 4/6 plus 3/6 is 7/6 power. Okay? So that's the exponential form, and to write it in radical form, we've got the 6th root. Let's get a different line here. All right, that's exponential. For the radical form, we've got the 6th root of 3 to the 7th. Well, because we have a 6th root, we've done this in the past, we could pull out groups of 6. So there's one group of 6 3's in there, so we're going to pull out a 3 and be left with 1 3 on the inside. So that's simplest radical form and exponential form. All right, and number 6, all right, we have to manipulate this to make it have the same base, and we can convert to radical form. Okay, so we have 5 to the 5/6 power divided by 5 to the 2/3 power, right? Because it's the same as 5 squared. So 5 squared gives us 5 to the 2nd. Okay? Now, when you have something like this, you can just treat them like regular exponents, subtract the exponents. Okay, so 5/6 minus 4/6 is going to be 1/6, so 5 to the 1/6 power. which is the same as 6th root of 5. All right. Lastly, solving the equations with powers. We're going to do very similar to what we've done in the past. Okay, so we got to isolate our variable. All right, divide both sides by 6. X to the 2/3 equals 9. And to get rid of our 2/3 power, okay, you're going to take each side to the reciprocal power of that. Okay, just like if you're multiplying by fractions. So we're going to take both sides to the 3/2 power, because 2/3 times 3/2 is 1, which just leaves us with x. So we need to do x to the 3/2 power. Now remember, you could do this in your head if you turn it into the radical form. So it's the same as square root of 9 cubed. Okay, well, the square root of 9 we know is 3, so it's the same as 3 cubed, which is 27. Okay, and lastly, we're going to get t minus 3 to the 2/5 equals 4. And to get rid of our exponent, we have to go to the reciprocal power, 5/2. 5/2. Those cancel out. We have t minus 3 equals, if you convert this, we'll have square root of 4 to the 5th. Square root of 4 is 2, which is 32. So we have t minus 3 equals 32, which tells us t equals 35. And that's all you got to do for section 1.